Welcome to the Passive House podcast, brought to you by Passive House Accelerator, a catalyst for zero carbon building. For news, inspiration, and connections from all flavours of Passive House, check out passivehouseaccelerator.com. Sign up to receive regular updates about events, get your technical questions answered, and contribute to the community forum. There's loads of free information for experienced professionals and people just starting out on their Passive House journey. We hope to see you at one of our construction, tech, or weekly Global Passive House Showcase webinars. In the meantime, here's this week's Passive House podcast. Well, welcome back to another episode of the Passive House podcast. I'm Matthew Cutler-Welsh, coming to you from a very wet and rainy Auckland in New Zealand.
I'm Zack Semke, coming to you from today a beautiful sunny Seattle, Washington, which is about to change. Nice. And it's going to be wet, but today is a perfect Seattle day.
Yeah, well, we've had a good bit of drenching here. Still relatively warm, but had some few blustery winds. I understand there's been some moderate rain across Australia as well, which is always welcome in various parts over there. Things are looking good, but the heaters are definitely out, and the power bill is climbing at my house. It's that time of year where I very much am aware of the non-passive house nature of my house. And the kids get up and draw on the condensation on the inside of the windows each morning. And if I'm up first, I'll put the heater on to heat up the lounge room. It's a sorry state of affairs, I have to say, in the Cutler-Welsh household in wintertime. But it could be worse, and I know it is worse for many people, which is unfortunate.
Yeah, well, and we heard, and this interview will allude to some pretty cold conditions in some historic buildings.
Yes, and student flats and various other accommodations.
Yeah,
which are even worse. All right, so before we get into that, we've got a few people to thank.
We do. So this week we have a very special sponsor of the week, and that's Emu. And Emu is your partner in passive is their tagline, and they help construction industry professionals navigate the journey from research to reality by providing a supportive community with access to training, services, and standardized systems. So Emu does all sorts of trainings. They've got an online certified passive house trainer or tradesperson course for builders that will have a link to, and in-person passive house boot camps and a bunch of other stuff. So they are the sponsor of the week this week. So they're supporting all of the work that Passive House Accelerator does. So we're very happy to have their support. I also want to thank our founding sponsors, 475 High Performance Building Supply, Bax Ingui Architects, Glavel Foam Glass Gravel, Minutair All-in-One HVAC and Dehumidification Units, Mitsubishi Electric Train HVAC US, Partel, Rockwell North America, Stillcorp, and Zola Windows. Thanks as well to our champion sponsors, Icon Windows and Doors and Proseco, and thank you to our stakeholder partner, NYSERDA, the New York State Energy Research and Development Authority.
Quick shout out from me to Emu. Probably one of the most prevalent attendees of conferences back in the day when we had lots of in-person conferences. Emu usually there at various passive house engagements around the world. So they're great presenters, and they've got great projects that they can speak a lot of experience to as well, which is awesome.
Yeah, definitely. Yeah, you can check them out at emu.systems. So emu.systems to learn more.
And they're not in Australia, by the way.
Right.
Although they're global, so they're online, so you can reach them there. But I always find it funny that meeting them on the other side of the world, and I'm the Australian, and they have Emu.
They're the one. They're the one
as their name.
They're represented with the Emu.
Yeah. But they've got a cool backstory. All right, let's get into this week's interview. I caught up with Priscila Besen, PhD, a couple of weeks ago. I've had the privilege of being a co-board member on the Passive House Institute with Priscila in the past. And she is now, having achieved her PhD a couple of years ago, is a lecturer in architecture at Huri to AUT, that's Auckland University of Technology. And she teaches there in their School of Future Environments, where they have recently launched an architecture course. I also had the opportunity to go and speak to some of their students a couple of weeks ago, and it was awesome. I've done a few lectures in a couple of other institutions, and it's sort of a typical environment going into a lecture hall and just talking at people for 50 minutes and then leaving. But they do things a little bit differently in AUT, and it's much more interactive, more like the lectures feel more like a tutorial. And I thought it was going to be tough, actually, because they were all finishing off some models on their desks and towards the end of their term, but we had a great session, and I think Priscila would be a fantastic lecturer for them. Her PhD was in the area of conservation of heritage buildings, and while none of the buildings that she researched have been certified to date, she was looking at them through a passive house lens, and she has some good amount of experience in passive house. So let's get into it. This is Priscila Besen. Well, welcome, Priscila, Dr. Priscila Besen. It's I've been wanting to get you on the show and have a chat about your experience with Passive House for a while. So great to make that opportunity happen. So welcome.
Thanks, Matthew. Yeah, thanks for the invite.
Now let's go back and tell us a little bit about your background in terms of architecture. How you were trained in Brazil, is that correct?
Yeah. So I did my architecture degree back in Brazil a few years ago. And while doing that, I had an exchange in the US. That's where I got to know about the Passive House standard. And then 2015, I moved to New Zealand and started doing more things related to Passive House.
What made you take architecture in the first place?
Yeah, I guess I was really interested in many different things. So I was always interested in the environment and sustainability. I was also interested in physics and maths, and I was also interested in arts and creative things. So I found that architecture was a way to bring all those interests together. Nice. And sort of using creativity to do things for a better sustainable future. So yeah, that's good.
You mentioned finding out about Passive House during your visit to the US. What did you think of it the first time you heard about it?
Yeah, so I was doing this exchange in New York, and I was, experiencing very cold winter there. And in one of my courses, one of the lecturers took us on a little field trip. They were doing a retrofit of a building in Brooklyn, in New York, and they were doing a blower door test, and everything was really new to me, but I found it was really, really interesting, and especially because I was living in a very cold building and very inefficient building, and finding out that there was a much better way to do things for comfort and for energy efficiency. So that was the first time I heard about Passive House and EnerPHit. And since then, I started studying and researching about it, and also looking into practice.
How do you think that experience with EnerPHit might have influenced what you've gone on to do with your research?
Yeah, I guess it was first inspiration about doing this work. So seeing that in practice was very interesting, taking a very old building, very cold building, and transforming it, improving it into a very nice, very comfortable and efficient building was really, really amazing to see that work. And then moving to New Zealand, seeing the building stock here and many of the issues we have with comfort and health, I always thought about doing things related to that. So either in new construction or also in existing buildings.
Yeah. So. Those buildings that you saw in New York, were there heritage constraints around those buildings?
Not really sure. I don't, to be honest, I don't remember very well. But yeah, they were, I guess there was like some heritage constraints, but they were not like very significant buildings.
Right.
So you had a lot of flexibility on what you could do on the facade and things like that. Yeah.
Right. So where did you come up with the, tell us about the topic of your research was looking at the possibility of high performance retrofits for heritage buildings. Is that a reasonable summary?
Yeah.
Why did you want to look at that?
Yeah, so several reasons. The main one was looking at what was happening in Aotearoa, New Zealand at the time, where there was new regulation that mandated the seismic retrofit of many existing buildings. And we had many tragic events of earthquakes in the past, which led to this new regulation. And one of the main building types or construction types was unreinforced masonry. So there are so many historic buildings built like this in New Zealand, and they're very vulnerable to earthquakes. So I was seeing that there were many retrofit projects taking place around the country, and they were only dealing with the structural side. So I was thinking things like they were doing this major project and they would be replacing single glazing with new single glazing. So They were not really taking the opportunity to do other improvements. Mm-hmm. So I thought there was really a missed opportunity, and I started thinking about how things could be done better. And on a personal side, a personal story also that inspired the research was that I was living in a heritage building myself, built in the 1930s. So I was also experiencing how it was like to live in a very cold and unhealthy place, but also a very beautiful building. So that's the main balance, because we have these really beautiful historic constructions, but it's just how to make sure we can continue to use them and make them healthier places for us to live and work in.
And that was here in Auckland?
Yeah, that was in Auckland.
Where was the heritage building that you were staying in?
Close to the University of Auckland in the city center. Yeah. So, yeah, it was an Art Deco building, very, very nice, but high ceilings and single glazing and no insulation, very, very hard to
thermal mass
heat.
On the outside.
Yeah. So a funny thing was that, like, I would turn on the heater and it would basically make very little difference. And I have a little dog, and my dog would cry next to the heater wanting me to turn it on. So
I think you're describing the experience of a lot of students, and probably sadly more occupants of houses, and particularly rental properties in New Zealand, of some pretty grim
winter conditions, and we're faced with this desire to retain some real heritage. I also see a struggle right now between people just holding on to what was with a lot of our suburbs and actual heritage. How is that a hard distinction? Do we have a good definition here of what is classified as a heritage building, and in fact what's worth saving and what is just old and probably should be knocked down?
No, that's a really big discussion, and I talked to many people throughout the research, so lots of heritage professionals and people working in Heritage New Zealand and things like that. So the main idea is that what we're seeing now here and overseas is really to try and give, I guess, more flexibility for heritage buildings. Mm-hmm. So balancing this need to preserve what is there, but also to find out ways to make them relevant for now and for the future. So with all the challenges of climate change, etc. So it's hard because it becomes really subjective, like what can you change and what should remain as it is. But I guess, especially in New Zealand, we do have a few different levels where we can see we can differentiate like a very significant building, say a church in the CBD that was built like 100 years ago versus a villa or bungalow that we have many examples of, which are sometimes considered as a character building, not really a heritage building.
Right.
So I guess in this cases, that's where we want more flexibility to be able to make changes to this kind of typology. Yeah.
I'm guessing that a lot of our audience will be, if not familiar, then they'll have some idea of some of the technical challenges of taking an older building and retaining some of its aesthetic while improving the performance. What were some of the things that you came up with? I'm guessing things like insulating, you mentioned glass. What are some of the big challenges of making something still look old but perform in a modern way?
Yeah, sure. Yeah, so there are many challenges, but also many interesting, innovative ways to do this. So one of the interesting things with windows was that there are many ways where you can keep an existing window. You keep the historic glass, but then you just add secondary glazing either to the outside or the inside. So that was a very significant finding when I talked to architects in New Zealand and also the ones that were, especially the ones working with heritage, that whenever I was talking about improving windows, they thought I was talking about complete replacement. So there wasn't really the knowledge about all the different solutions and, the level of upgrades that you could do. And this is just, one example that was very common overseas. I went to visit a few case studies in Europe, and that was really common practice in many buildings. And then in New Zealand, it was very hard to find examples like this. So, just one of the examples. And then the other one is wall insulation. So that's one of the main challenges because with most of listed heritage buildings, you want to keep the facade intact. You want to be able to see all that historic fabric on the outside. So that leaves you with the option of insulating from the inside, which we know is not the ideal, but that's mainly what you need to do in that case. So there are some materials that are coming up, lots of research on that, on capillary active insulation to be able to allow to prevent any interstitial condensation and moisture issues. So I guess those are the two main areas that I looked at.
Yeah.
And
that whole building science area and what happens to moisture when you insulate a building that wasn't previously insulated. I mean, that's a important and very interesting topic. Focusing in on the EnerPHit standard, so your research was theoretical, sort of a desktop study of what could be done. What were your main findings in terms of what it would take to take some buildings that you looked at, or give us a rundown of the buildings that you did look at, and what were the bottom line findings from your research as to how much cost or what kind of interventions it would take to get them to the EnerPHit standard?
Yeah, sure. So I looked at 3 case studies in New Zealand. They were university buildings, all built of unreinforced masonry construction. So I had a look at their current performance first. And what was interesting was that one of them was using 40% more energy than similar buildings. They all had several problems with comfort. We did some IEQ surveys as well to understand how they were currently performing. And then we looked at some retrofit scenarios, so ranging from very simple interventions and then going up to more complex interventions. So starting from a baseline model, the current situation of the building, then starting to add ceiling and underfloor insulation, which can be quite simple to do. Then looking at adding heat recovery ventilation systems, then looking at improving windows, as I said, with secondary glazing. And then lastly, we left this as the last intervention, the addition of wall insulation on the inside. So looking at these models, we found out that we could achieve up to 90% reduction in heating demands.
Wow.
Comparing the baseline with the last scenario, so with the wall insulation. So there's a lot of potential, a lot that could be done.
Yeah.
And one of the things I should mention, as we were working with integrating the seismic and the energy retrofit, was that we started to look at some structural systems that could also help with the energy performance. So,
right.
For example, in one building, they were adding plywood diaphragms to the ceiling. So that could help with your air tightness, for example, if you were sealing it properly with tapes and things like that.
Yeah.
So one thing could be like a win-win working with this structural and the energy side.
Yeah.
And in terms of costs, that was one of the limitations of the research. So we couldn't really calculate costs, especially because one of the main components would be the labor costs.
Mm-hmm.
So that's quite hard to predict in a retrofit project, especially in a retrofit of heritage. Yeah. So we know there is the potential, but certainly more studies are needed in terms of costs and I would say.
I'm guessing that the seismic improvement might be more of an immediate driver for some of these projects. So would it be the case that if a building has to go, I mean, we just had the case this week where a whole ward in a hospital just outside of Wellington was basically shut down because it was discovered that it was not up to the standard. And that's unfortunately not uncommon here. And then there'll be lots of busy work to try and address that. Is that a good opportunity to try and do some of these other thermal benefits and energy efficiency benefits at the same time?
Yeah, certainly, because many of the professionals that I talked to highlighted that, when you need to do this structural upgrade, you have all this cost of moving people out of a building, which is a major thing to do. And then you have, all your construction in place, you have scaffolding, you have, all the workers there, everything's prepared to do a major renovation. So once you have all of these things in place, then, changing a window wouldn't be maybe such a big deal comparing to, taking a building that is working and is problem. And like that was the idea of the research. I thought it was not very likely that you would have a building like that wouldn't require a renovation, and you would decide to do a major energy upgrade just for the sake of energy efficiency. I think in New Zealand that's quite uncommon. But if you have a major renovation going on, then to add a few more things wouldn't be such a big issue. So that's the main opportunity, integrating everything you can in a major renovation, major retrofit. I
want to go back to the term you mentioned to distinguish buildings that aren't necessarily classified as heritage, but someone just might like the way they look, but they perform really badly. Have you looked into how we should decide what is worth keeping and at what point something is just it's too far gone, or it's going to be too expensive, or it just doesn't have the or perhaps the land that it's sitting on is so valuable for being able to house more people? Have you looked into ways that we can help with those decisions?
It was not really my focus as I was working with buildings that were actually listed and protected. So that was, I guess, one of the reasons I chose those, because, these buildings will need to be here, they will certainly be here in 100 years. So these are some of the buildings we should be focusing on retrofitting, because we are certain that they will be, around. With the other ones, there's always the possibility that they will not be here pretty soon. But certainly there are some research projects that do create decision-making tools to balance all the factors in understanding if it's worth keeping a building, if it's worth renovating, or if it's worth demolishing. But one thing I would like to add to this discussion, because there's a lot of this talk in Auckland about the character and the heritage and things like that, is that, they do, even though some buildings might not have a very high heritage value, having a mix of building ages in a neighborhood adds so much value to the urban environment. So we shouldn't, in some cases, I think we shouldn't just be demolishing everything for the sake of, increasing density. We should be looking at keeping a few and keeping a mix. But so it's not just a one-sided approach.
Which is hard, because zoning covers a whole area, or, all the way along a particular road or a suburb. And it's you can't really go along and say individual sections and pick and choose which one, from a town planning point of view, should be allowed to densify and which ones aren't. But I know, land, and that's what we're seeing certainly around the part that I live in Auckland, sort of relatively central, where beautiful villas are just taking up really valuable land, and you can put 8 townhouses on one section. I'm not a land developer, but I'm pretty sure the economics of that stack up relatively well. So probably less so this year than last year, but with the price of inflation. But it's tricky. But I also think from we're talking a lot about embodied carbon and the fact of retaining some of the resources that are already there, and it's such a shame when you see a beautiful old building just get smashed up and pieces taken off to landfill.
Yeah, and sometimes really high quality materials as well. The timber you used to have in these buildings, and
it's incredible.
Hardwoods. Yeah.
Native hardwoods. So it's nice to see if it is going to be removed for that house to go on the back of a truck and be used somewhere else. But I understand that that's not always economic or possible. So it's a tough equation. Did you, or is it possible to come up with a standardized approach or at least some guides, like a design guide for retrofitting, or is it so bespoke and dependent on the individual building?
I guess we can come up with methodologies, and one of the ways is, of course, to use EnerPHit as a guide. So there is the step-by-step approach that you can do with EnerPHit, that you could do a retrofit along a number of years. So that's an interesting way to look at it. And then, there are studies like mine that show a few examples for a few case studies, but you could certainly replicate that to other buildings. And then in terms of balancing the heritage side with the energy retrofit side, there are a few standards in Europe. The one that I used was called EN 16883, I believe. So it's an energy guideline.
That just rolls off the tongue, doesn't it?
Yeah, it doesn't really matter. There's like an energy guideline for upgrading historic buildings, something like that. So it's creating a method for this decision-making process. So you are balancing each intervention and looking at the benefits in terms of energy efficiency and comfort, and then the risks or the downsides that carries. So understanding if it is worth it or not for each single intervention. Yeah, but it is, you have this methods and general approaches, but at the end of the day, it's quite bespoke. You find that a lot of the materials are different in these buildings. There's a lot of variation. You have this beautiful decorated facades that are different in each case and different windows. So you can use this main guidelines, but of course the design team needs to design very carefully with what you have.
Nice. Yeah, because I really like it when people can not have to reinvent the wheel and learn from what's been done previously. But I also appreciate that working with existing buildings is some of the hardest design and construction work to do. It's much easier starting from scratch. But a lot of these buildings, you don't even know what you're going to find until you start the work. So very challenging and hard to come up with standardized methods of achieving something like EnerPHit on a historic building.
Yeah. And in studying this, I went back to thinking about new construction and what a missed opportunity it is to not, to not be, designing to passive house or to high performance standards in new construction, because it's just so much easier to do it right from a new building than in an existing building.
I think that it's such valuable work for any architect to have the opportunity to go and look at existing buildings, particularly during a renovation or in building surveying work when you get to do destructive testing and diagnose problems, because it's such an important way of learning firsthand where buildings can go wrong and the types of issues that they can have. And if you witness that firsthand, I think it's going to make you much better as a designer to avoid repeating those mistakes in future designs.
Yeah, exactly. Yeah. And we can learn so much from historic buildings in many aspects. Yeah. So that's one of them.
Speaking of future designs, you're working now as a lecturer at Auckland University of Technology. What are your feelings about future generations of designers and architects?
Oh, good question. Yes, so I'm actually teaching at the School of Future Environments. So it's a very future-focused approach. It gives me a lot of hope to be teaching these students at AUT.
Nice.
I see a lot more interest in sustainability and in the environment, and we're focusing a lot on regenerative design. And I think they are still, working with the technical sides and things. But my view is that if they have the empathy, if they really care about these things, then they will be able to learn and design in a better way. And I mean, it takes a while to learn all these things, and passive house can be quite a challenge to learn everything about it. But I do have a lot of hope for our future designers. I think they will do a really, really good job. Some of the things we're talking about are design for deconstruction, for example. Some of things we didn't talk much about in the past. So, and the students are very, very interested in these things, and the circular economy, zero waste, and also
awesome
energy efficiency, etc.
Very good. Hey, well, thank you, Priscilla, for your time and also for your work that you've done in the Passive House community, been on the board here at Passive House Institute New Zealand, and now really important work as a lecturer, inspiring all those young designers. And thank you for your time on the show. It's really great to have you on and hear about your important research.
Thanks so much, Matthew. I really enjoy listening to the podcast. So looking forward to the next episodes.
And that was Priscila Besen, PhD. She is a researcher. Actually, she's doing a little bit of research, but mostly teaching now at Auckland University of Technology. It's a great look at some of the issues relating to preserving what deserves to be preserved, and figuring out how that can be done as close to Passive House as possible. What do you think, Zack?
Oh, great interview, and really sounds like some miserable conditions inside some of these buildings. her dog crying for the heater to be turned on. Oy, oy, oy.
Yeah,
that's rough.
Yeah, it's a sorry state of affairs. I was actually in another presentation just last night talking to some German manufacturers and suppliers who are looking at selling energy efficiency in New Zealand, and we do this sort of thing occasionally with the German New Zealand Chamber of Commerce, and it's always a bit of a challenge, I find, just to explain the reality of what some house conditions are like here, and people are very surprised, not least the people that come from overseas and say that they've never been colder. And it's not a freezing cold environment. I mean, we're a temperate climate, but it is heavily influenced by the maritime environment because we're a long, skinny island with lots of water around. So we do have relatively high humidity. It's sort of ambient humidity of about 80% on average. But I think the other contributing factor is that we almost get away with it each winter, and the winters are cold and they're damp, but because you can kind of survive through them, we've developed a culture of just putting up with it and it's almost a rite of passage for some students to go through a cold, miserable winter in a cold, damp flat. And we joke about these things, the stories in Dunedin of students at Otago University that put their beer in the fridge so it doesn't freeze if they leave it out, because it's, the kitchen gets colder than the inside of the fridge. And it's funny and it's great for stories, but it's also a contributor
serious
to the fact it's very serious. We have the second highest rate of asthma in the world. We have huge, really high rates of respiratory disease, and that was all before COVID came along. So it has a long chronic effect on the health of people, and that's also why it doesn't get the headlines, because it's a chronic, ongoing issue that I've said to people that our houses kill people slowly, and that's why we don't notice.
Mm-hmm. Right. And then you have the really serious issue of energy poverty, which you had a guest on a few months ago on the podcast, really, exposing that and looking into that. So that's I chuckle when I think about the students in their beer fridges, but it's actually, it's not really a laughing matter when it comes down to it. So I was really struck by, of course, whenever I hear these another firsthand story of the kind of wood tent issue. Not always. Some of these are masonry buildings too, but
they're still tents. We have some concrete tents as well.
Right, exactly. So I was also this whole opportunity, I guess, of seismic upgrades to enable the energy efficiency interventions, or the performance interventions in the buildings was I think really a powerful one. And it reminds me of the work by Architecture 2030 around research into how to make deep energy retrofits feasible, and just how critically important it is to time energy improvements in existing buildings with the normal capital improvement kind of schedule. So you have these, it's so much more expensive to decide, okay, I'm just going to do an energy upgrade right now, and just do it versus, okay, well, this is the time because this certain piece of equipment needs to be upgraded, or, hey, we actually need to bring this into line with seismic codes, or, you have what have you, makes it, can cut the cost of the energy improvement by 2/3. So that was, we need to think about, like, where are it's not really low hanging fruit, but what are there are some smart ways to start with that big task of retrofitting all of our buildings.
Yeah, it is. It's an interesting, like I say, it's opportunity. It's come to a greater awareness in the last decade since Canterbury, and we've had ongoing earthquakes and very aware of being on a fault line. That's why why New Zealand exists. Right. The Southern Alps is formed on the junction of two tectonic plates. So we wouldn't be here if we didn't have seismic activity. But it's a reality of the places we've chosen to live, and so that we've got that going on. We've also got the pressure on the availability of housing. So that also leads to lots of conversations about what's worth keeping and what areas are valuable and what else could be put in their place. So that's a big and that's quite a popular story as well, in that it reaches everyone, and talkback radio and media about. You get one side of the story that there are beautiful villas in leafy suburbs that are seen as a really important part of our heritage to retain. And other people who say, well, that's just elitist, and that's really valuable land, and it's close to public transport, and you could put 8 houses, modern, warm, dry houses, where there's one big old energy efficient timber tent that just happens to look beautiful and have a swimming pool. So there's some real cultural challenges there as well. The unfortunate thing that I find with all of this is that it's very hard to do it on a total urban scale, which would be the ideal way to do it, because a lot of this is private property, and unless it has some sort of protection on it, then it's left up to the general rules of the area and the appetite of a private owner as to whether they want to retain that historic look, or if they want to make a bunch of money by knocking that house down and building an apartment block or a townhouse, which may or may not be the best thing for that piece of land. But the point is that it's very hard to organize that in an equitable way.
Mm-hmm. Yeah, I was also struck by her when you were asking about, how do you determine what buildings are historically significant, and what is this, kind of like, how do you approach this? The idea that she shared about, essentially, how do we make these buildings relevant and useful going forward as well? So it's conserving, it's historic preservation and conservation, but partly it's also that it sounds like there's a little bit more flexibility now, at least it sounds like in New Zealand, to be thinking about, well, yes, we want to preserve it and also be flexible so that we can make these buildings really, useful for people for another 100 years. Given that we have, this is an era of climate change, and so we need to be resilient to that. We also need to mitigate it. So it's a really interesting space. That confluence of thinking about climate-wise buildings and historic preservation and how they interact.
There's one of my other favorite commentators on this topic to listen to is another senior lecturer at a different university here in Auckland. Is Bill Mackay, who talks a lot about urban redevelopment in New Zealand, and he's a bit counter to a lot of his peers of his seniority, in that he often advocates for removing more. He tends towards replacement of some of our older buildings towards more modern homes that can be drier, warmer, and lower carbon. Which and he acknowledges that can be a controversial viewpoint amongst his peers, because there's a lot of people, particularly in the sort of high architecture end or the traditional architecture end, who really value. I guess they see a lot of the work of their people that have inspired them as art, and as something worthy of preserving. I think that needs to be taken into account. I think we don't want to have monolithic buildings that all look the same and just big glass boxes or even concrete boxes. So we need to get a balance there, and it is a tricky thing to achieve. And I don't know, I think it's not just an Auckland problem; it's a problem around the world. New York's a great example of where they're grappling with this as well.
Yeah. Yeah, definitely. Another thing that just came to mind was, I love the name of her institution, the School of Future Environments. It seemed like that's a great.
AUT's they're doing some cool stuff at AUT. They're sort of the newer the kid on the block are amongst tertiary institutions, and they're doing some pretty funky stuff. Yeah.
I love thinking about architecture as the the creation of future environments. And the retrofits as well, as retrofits of a historic building, you're still creating this future environment. So great interview. It was really, really fascinating and great to hear another perspective and another person grappling with this big problem that we need to solve of doing retrofits, and how to make them work, and how to do them. Well, I mean, she mentioned that her focus wasn't on calculating cost; it was more on the technical feasibility. So, but there's all these smart people are chipping away at this. Yeah, it is big. It is the next challenge, big one.
All right, what do we got coming up?
Yeah, so we have on Passive House Accelerator Live, we have a construction tech edition of the show this week. So this is Wednesday on my time, Thursday your time. And we are joined by Doug Press of Midwest Efficiency Supply. And he's going to be presenting the Window Geek's Guide to Installs, Field Problems and Solutions. So we're all really looking forward to this kind of survey of high performance and passive house window installation tips. So don't miss that. And then big news for us in North America on Passive House is that the Passive House Networks conference is kicking off on the 10th. So that's the 11th your time. But it's so this is the 10th of June will be the online only segment of the conference, and then the following week, the 17th, will be hybrid. So it'll be both in person in Boston as well as online. So folks from all over the world will be able to take in the Passive House Networks conference. So we'll include a link in show notes for that. And just another shout out to EMU and their support of the Passive House Accelerator as a sponsor of the week. We're really happy to have their support.
Awesome. So much going on, as always. Well, thank you, Zack.
Thank you, Matthew. Great interview. It was really fun.
We'll be back again on the pod next week with another interview. So until then, we'll see you next time on Passive House Podcast.